people disappointed because they can't get a hold of that stuff. And that's just the way it is today. The administration cuts out classes like there's, I don't know.
That was very sad.
Yeah.
I don't think, did that have to do math too, or just,
Oh, yeah.
really?
And then and the president then hires 4 more math teachers. So you don't know what's going on.
Don't tell me you're the board of directors, right? Explains kind of that.
Good afternoon. It's afternoon, right?
Yeah.
My name is Suzanne Masala, and I'm one of the counselors. And I see some familiar faces, which is always really nice. When I came in because I want to talk to you about registration, it actually started today for summer. And the first group that will register for summer are veterans, active military, foster youth, CalWorks, EOPS, and supportive services. So those groups go first. And so it depends on what your priority is. And each of you has a different registration priority depending on how many units you have and things like that. And if you wanted to find out when you can register, you go to WebReg, which is the site that you use to register for your classes. And that way you can find out when you can start to register. Okay? But as your instructor was just saying, especially math classes fill up like that, because everybody needs math, right? And so you want to make sure you register as soon as you can, so you have some choices about what time, and who, with whom, and all of those things, okay? I gave everybody a paper that has the information on it. I would love to see everybody one-on-one to help you figure out what direction you're going in. And I know some of you probably already see another counselor, and that's fine. You don't have to come and see me too. I just want to make sure that everybody knows that there's counseling available, okay? And what we do is we'll help you figure out a plan that you can follow towards your goal, okay? That's called an education plan. The education plan is easy once we figure out what you're going to do. Sometimes the hardest part is figuring out what you're going to do, right? A lot of people are like, I don't know. So come in though, and we'll have a conversation about what you're interested in. And just try to get some ideas going as far as some of the things you might want to take a look at to start to think about a major, okay? California community colleges are going through this huge change right now. Used to be you could hang out for years in community college and never have to pick a major. That was the old days, right? They decided, the state of California has decided, nope, we're going to have, students have to get directed faster than they did in the past. People are wasting too much time. Now there are some pluses to that in terms of helping people get on a path more quickly, right? But there are also, it's going to be interesting to see how do people do picking a major right away. Okay? So use us, use the counseling, use all of us to help you figure it out. Okay, we can help you, we can show you how to do research, we can help you do research with you as far as what's out there. You know, it's hard to know what you're going to do if you don't know what's out there. Usually we know maybe like 20 occupations, right? We know firefighter, we know doctor, we know nurse, we know teacher. What else? Mechanic. I knew that was going to be the next one, right? What else? So we're thinking of 5 right now, right? On a Monday at 12 o'clock. But I bet you, I think there are thousands.
Law enforcement.
Law enforcement, right?
Design.
Forestry, design, right? And the arts.
Administration.
Administration.
Drama.
What'd you say?
Florist?
Florist, drama, right? So there are things out there that maybe you don't even know they exist, that you could train for that you would like to do, but you don't even know it exists.
Oh, I can't forget one, automotive.
Automotive, right? Yeah. So the main point, though, is to help you start to think about which way you want to go, right? Because if you don't know where you're going to go, it's hard to stay motivated in school, right? It's hard to go to school, isn't it? This is your first semester for most of you? No, not your first semester. It's still hard to go to school, right? It's work. You have to get up, you got to do the homework, you got to do all these things. It's easier if you have a goal, though, because then you know why you're doing it, right? When I talk to people who want to be nurses, those guys are on fire. They're going to do everything that they have to do. They study all the time because they have a clear-cut goal, right? So what I hope for you is that you can find something that you can work toward that'll make it so that you are motivated to be in school and you do the best that you can. Registration for fall starts on May the 8th, and again, that'll start off with that first priority group, so you might not be able to register on May the 8th, but I want you to know that the process starts now, okay? And you're going to look at WebReg to see where you can actually register. Okay? You can register for classes here, you can register for classes in Marina. Make sure if you register for a class in Marina, you know it's in Marina, right? That happens all the time when people register for a class somewhere else and then they show up here and they're really late for the first day because they have to jump back on that freeway and get to class. Okay? So I really encourage you, just use us, make us work. This is our job, this is what we do. And it can be a really good thing to find someone that you can work with that can guide you on your path. Okay? I'm standing in front of you now as a counselor, but I wasn't always doing this. You know, I was sitting exactly where you're sitting. You know, I was a student at Cabrillo College. I was really fortunate to find people that were like, they were so helpful to me. They really wanted me to make it, and I can feel that, you know? And so it's a great pleasure for me to be able to work with you guys and help you on your path. So I hope you'll come and see me or the counselor that you normally see. And do you have any questions? Any questions? Okay. Oh, yes, ma'am. I knew somebody had one.
So May 8th is priority registration?
Pardon me?
Is May 8th priority registration?
Yeah, so if you're in EOPS, CalWorks, you're a veteran, active military, there are a couple of groups that get to go first. So they will start then, and then I bet most of you, if you have less than 30 units, they're probably going to start around the 12th or the 13th, okay, but you want to find out. You just want to register as soon as you possibly can, okay, and if you need help putting the schedule together or anything like that, come and see me, I'll be happy to help you, okay. There's a sign-in sheet going around just because I have to get you to sign, I have to keep track of who I see. So I'll just kind of hang out and wait until that's finished and then we get on with the math, okay? It's good for me to see the math classes because math was challenging for me. And I notice when I come to math classes at MPC, I don't get a stomach ache when I walk into a class. I don't. I used to feel kind of sick in my stomach when I walked into math class years ago. And I noticed, you know, the atmosphere is really nice, so you guys are lucky. So I'll be here, okay?
Thank you,
You're welcome.
Suzanne.
You're very welcome.
I'll move this over to the side. Because it's not shareable when we start.
Oh, sorry. Well, thank you.
All right, we're looking at homework in 8.4, circles, circumference, and areas.
Excuse me.
I just want to get into the conversation here about early registration. This priority system is brand new, so we'll see how it works. But the point is, don't wait. Register as early as the system will allow you to register. Because not only, there's a lot of subtleties to it. For example, if you want a certain teacher, you can be sure that a lot of other people do too.
It's hard to register right now not knowing if, that's the class.
They
It's
want,
all till
Don't
May
wait
8th.
till you know whether you pass or not. No, don't do it. Go register.
Can
Soon you're gonna pass.
I address that?
Yeah.
That's so important. Many students think that they have to wait to find out if they passed the class before they register, but don't wait.
No, don't do
Just
that.
go with a positive, you're gonna pass, and then if you don't pass, then you can rework it.
You can always drop it.
Yeah.
So it's
Yeah,
not.
that's really important.
Gotta fill the seat, right?
Wait, so there's always been priority registration at MPC, hasn't there?
There's always,
Been priority registration?
not that I'm aware of.
Really?
I've tried to register.
I mean, there's always been certain priorities, but not,
Yeah.
what they've done now is put everyone on priorities.
Oh,
So, I mean, that's what Suzanne was saying. But you have to check your priority online, so you'll know what date you can start registering. The reason is, I don't know if you spoke about this, but evidently, if everyone just, starts registering right away at the same time, it crashes the system. So it's not stable enough to take that.
Well, I just know that like disabled students get priority registration, athletes get
Oh,
priority.
yes, that's always been there.
Oh,
Yeah,
okay.
that's a different matter. But the whole idea is, for example, my fall classes will be filled, what did it say, May 8th was the beginning? My fall classes will be filled 5 days later. That's it, done. That's the way it is. And it's that fast. So
Are you teaching the next level of this?
I am. I don't know exactly when, but. Yeah. All right, so let's look at 8.4. We're looking at the circles and so forth. Any questions?
63.
53?
63. Yeah.
Okay, they give us a circle and they tell us a radius. The radius goes from the center out to the edge. 5.1 feet. And they're asking us to find the area and the circumference to 4 decimal places using the pi key on your calculator. This is unusual for them to ask you to use that key. Most of the time they'll ask you to use 3.14. Okay, so we want circumference and we want area. Now, there are a couple formulas for circumference, and you just choose the one you want based on the data you've got. So we've got radius here, so we would use the circumference formula of 2 pi r. The area formula is, there's only one given, and it's in terms of the radius, pi r squared. Okay, so those are the two formulas we're looking at. This is the r, they give it to you. You don't have to figure out what it is, it's given. So you start putting in. So C in this case would be 2 times pi. Now they're asking you to actually use the pi button.
Yeah.
Is there anyone who doesn't have a pi button on their calculator? It's pretty common today, so that's good. And then you put in the radius, which is 5.1. And over here, same pi button, and then 5.1 squared. Okay, now this is meant to be a calculator problem, so let's look at the button pushes for it. For the circumference, it's going to be 2, of course, just put that in on the keyboard, times, which is usually that button. And then, in this case, you push the pi button. You don't put in 3.14 because they want you to push the pi button. And then 5.1, and we need a times in there also. And 5.1. Now, the only thing the calculator cannot do is read your mind. So it doesn't know whether you're done or not. So the way you tell a calculator, I'm done and I want the answer, is to push the equals button. That means, okay, now give me an answer. And then it should come out.
That was the reason
Yes.
why. Okay.
So let's see what we get here. Yes.
Yeah, well, that's the problem. You solved the problem using the calculator. So why using pi on the calculator would be different than the 3.4? Because they're going out to 4
They're
digits?
going out many more decimal places.
Because I tried going out further, and I still couldn't get the exact answer.
Well, let's just see what happens. Let's calculate.
This way it works with the key.
All right, so 2 times, and this is terribly embarrassing. My pi button is up above something called EXP. All right, so here we go. I have to push an extra button to get to my pi button. Probably you don't, but more modern calculators have it right there on the keyboard. So I'll have to go up to second, and then pi, and then multiply again, and then 5.1, and then equals. What I get here is 32.04442507. Now, it's putting out 10 decimal places of digits there. But at the beginning of the problem, they say round to 4 decimal places, which means 4 places past the decimal point. So we're going to round over to this region right here. And the way you do that, of course, is go next door. 5 or greater? No.
No.
So you don't change that 2, you leave it alone, but you do drop these. You don't put zeros there, you drop them, like that. Okay, if you put zeros there, you're indicating that you know what those numbers are and they're 0. Well, that's not true, they're not 0. Okay, so you want this to be as representative as possible of the right answer. So technically, if you wrote this down on a piece of paper, you'd have to use the squiggly equal signs because that means it's approximate. 32.0442. Okay, now let's do the area. The area is going to be, again, the pi button, which is a button in its own right, times. Now, this times, you can do powers. And because we're doing the second power there, it's actually pretty easy, and I think everyone will have the right button here. You take the 5.1 and then multiply it by the power button, but the x squared button is its own button. And generally speaking, that kind of thing will work. It depends on the programming of the calculator. The parentheses that you see over here, including that 5.1 inside as the base and then the 2x1, sometimes with some calculators you actually have to put those parentheses in, and others not. It's just kind of strange, depends on the programmers. So let's see what I get here. And I do have an x squared button. So I get 81.71228249.2. So it looks like mine does not require the parentheses. To be absolutely clear, when you're giving the calculator commands, I would put the parentheses in. How would you do it? It would look something like this. Pi is a button now, so times, and I would put open parentheses in there, which you should have if you have a scientific calculator. You should have parentheses. And then 5.1, close parentheses, and then x squared, and equals. So that's how you would put them in. Now that's being very clear to the calculator. What is it going to raise to the second power? This, the thing in parentheses. Okay? If you, for some strange reason, were putting a negative number in there, you would definitely want to put parentheses around the negative number because you want the entire thing, the minus sign and the negative number, to be raised to the power. So it's good to know how to use parentheses if you absolutely need them. Okay, now chopping this off again, they want it to the 4th position, which is right there. 2 is not 5 or greater, so we would say that's approximately 81.7128. Okay? So this is getting used to how to use the calculator when you're dealing with decimals, and especially these endless, non-repeating, non-ending type of things. It's a good idea to do that because practical work is done that way. Most of the time, when we're dealing with natural things, like circles are natural, we have to chop things off because you got pi right in the center of everything, and that goes on forever. So you've got to make the decision where to cut it off. You know, in this case, they told you go to that 4th position. In a real situation, you'd have to make that decision. Any others? 37. Okay. It's got a circle. Not surprising. This time they give you a diameter. And the diameter goes through the center but touches 2 points on the circle. And that's given as 42 inches. And they say, find the area of the circle, give the, in part A, give the exact answer in terms of pi, and part B, use 22/7. Okay. So we're having two areas. One will be pi. Of course, pi r squared is the formula. And part A, they want us to use the actual pi button. Okay? And that gets multiplied by r squared. And r squared here, now you've got to be careful because that's the diameter, that's not r. So if you want r, you have to take 42 and divide it by 2. Half of that will be the radius, which is 21. So you want 21, and then again, you can use the x squared button. And that will give you an answer for part A using the pi button in all of its glory. Well, they didn't want you to push the pi button, they just want you to use the letter pi. Okay, picky, picky. So this becomes pi, and then you want to square 21. Now 21 squared is 441. So in other words, the exact answer, A, will be 441 pi. Now, there's not a whole lot of reason for that. I mean, just the letter pi, maybe if you were publishing a paper or something like that, that would be useful. But, you know, for down home kind of work, it's a Greek letter. How's that going to help you do anything? It's strange. Okay, part B says, on the other hand, you can use 22/7. So in part B, you're going to take pi as 22/7, and then multiply it by 21 squared. Okay, well, let's see what we can do with that. 22/7, let's write that as 21 times 21. That's what squaring means, right? Multiply the number by itself 2 times. And now we can do some canceling, right? Because the 7 in there cancels with the 7 in there, leaving you with a 3. So you have 22 times 3 times 21. And when you use that as your value of pi, remember that's not an accurate value for pi. It comes out to be 1,386. So that's an approximation. Remember the 22/7 approximation for pi, it's only good out maybe to here's where it starts changing. I think this is the point where you start getting some change. So 22/7 comes out with a 2 there. Pi itself actually only has a 1 there. So if you're interested in accuracy that goes out to 1,000, you don't use 22/7. Okay, it's one that's rarely used. It's only used in books. With carefully chosen radii, so you can do these canceling things. But really, in real life, that doesn't happen very much.
Is that the only formula you can use to get that answer?
Yeah,
Since you used
this
the
is
half?
this is the area formula. That's right.
Can you do the A equals half diameter? Can you use that one? 1/2?
Not for, the formula for area is not presented in terms of diameter usually. I mean, you can figure it out. But the one for circumference is, which I've already erased. The circumference one, if you were talking about the circumference of this, you could get it directly by multiplying pi times d. So that would be 3.14, let's say, multiplied by this entire thing, which would be 42. And that would give you the circumference right away. Yeah. But area, for some reason, is never written in terms of diameter. I don't know why. It just is. Okay, any others?
47?
27?
47.
47. Oh, ice cream cone. Everyone's favorite problem. Okay. So you have a composite shape here. We've got half of a circle and then a cone, or a triangle actually, that goes down like this. This distance is 4 inches, and this distance from here to here is 6 inches. So they want the area of the whole thing. Okay, so we're putting two things together. One thing is the triangle that you see there, the lower triangle, and the other is the half of the circle. So let's do the triangle first. The area, we'll call it A with a little t after it for triangle, is going to be 1/2 base times height. No? 1/2 base times height. Now the base for this triangle is up on top for some strange reason. It's flipped over. So that's your base, there's your height. So it's 1/2 4 times 6. And you can do some canceling there. So that gives you 12, and that will be in square inches, which you can write as inches below exponent there. Okay, so that's that much. Then we want this one up here. Now that's a circle formula, but the entire circle is pi r squared. So actually, we're just interested in 1/2 of that, so you want to take that and divide it by 2. So half of that's going to be 3.14 times r. Now, the radius of that circle, you'd have to take that, that's the diameter right there. So its radius is going to be 2 inches, 2 squared, and then divide by 2. And you can cancel one of those 2's, that's okay. So you get 6.28, and that would be again in square inches, 6.28. And adding those two together, the total area then would be the area of the triangle plus the area of the circle, or 1/2 the area of the circle. And that's going to be 12 inches plus 6.28 inches, or 18.28 inches squared. Everyone okay with that? All right, anything else, 8.4? Okay, well, let's go on to the next section, which does what's called volume. Now, we've talked about perimeter, we've talked about area, and these are very much physical things. There are certain measurements that we can make in what we call our time and space. And our time and space is made up of 3 dimensions, not 2. At least to our thinking it is. So, perimeter would be measuring that plastic strip down at the bottom of the wall all the way around. You simply want to know what the distance is all the way around the room. And it's distance, so it would be feet or yards or something like that. If you want an area, then you want to put these little squares down, very much like the carpet squares, and just simply count up how many of those squares you have. And each one is 2 feet wide, so you can figure out, you know, this is a 2 foot by a 2 foot area. That's called 4 square feet, okay? And then I've got 20 of them. All right, then you multiply by 20, and you get the area. And it's a 2-dimensional area. It's not a 1-dimensional, so it's going to be in feet times feet, or square feet. Now volume. Well, we have a 3rd dimension, that one up there. Okay, so we can go into 3-dimensional space and ask about the volume of the air in the room. How much air does this room hold? And for that, you're going to have to start talking about not unit squares like the carpeting, but unit cubes. And much better to look in your book than me trying to draw something like this. Unit cubes are 3-dimensional cubes, you know, like sugar cubes and things of that nature. This one here, the small one, and it's 1 centimeter on a side, very small measurement. And each side is 1 centimeter, so if you wanted the volume of it, you would multiply the height times the width, that would be 1 times 1, times the length, another 1. So you had 3 ones multiplied together, and each one of them is a centimeter. So it's a centimeter times a centimeter times a centimeter. So you've got centimeters multiplied 3 times. And therefore, that unit cube, which is 1 centimeter on a side, one centimeter, 1 centimeter, 1 centimeter is going to be that multiplied by itself 3 times, which is 1, but the centimeters multiply also. So instead of being square, it's going to be cubed, 1 cubic centimeter, which is usually abbreviated 1 cc. Remember back to the metric system, we talked about cc's, cubic centimeter, huh? It turns out that the cubic centimeter is in the metric system also a milliliter. They're the same thing. It's the same measurement, same distance. Now, you don't have to use a unit cube of 1 centimeter length on the side. You could use 1 inch, you could use 1 foot, 1 yard, it doesn't make any difference. But that would be your unit. And then you stack up these units in the room and find out how many you have. And that's how many cubic centimeters or cubic yards are in the room. So you're using a base unit and you're just simply finding out how many fits in this particular space that you're interested in. Now, instead of doing that from scratch each time, what they've done is create formulas for volume. And as far as we're concerned, we're just going to plug into formulas. The concept of volume is pretty easy to visualize, but actually creating these formulas and getting some of these formulas mathematically is not so easy. Oh, it's not bad when you're dealing with a rectangular box or something like that. That's fairly easy. But when you start talking about cylinders and cones, that takes calculus. And calculus is taught here. It's a very beautiful form of math, but it's pretty advanced. And only calculus gives you these things that are more advanced, and it's just simply not within our ability to do. So we're going to look at things like a box, the shape of a rectangle. And we'll give it a length, L, and we'll give it a width, W, and then we'll also give it a height, H. Well, you might guess that if you're taking little unit cubes and stucking them in there, that you could simply add up those unit cubes and get a result. What you would get for the volume, V, is the product of length times width times height, which makes some sense. You know, if you had something like, let's put some numbers on it. Let's suppose we had something like 8 inches on the side here, 6 inches on the side here, and 2 inches up. Then the volume would be the product of 8 inches times 6 times 2. So that's 2 times 6 is 12, and 12 times 8 is going to be 88, 96? No, 96 inches cubed. 96 cubic inches. Now there's a version of the box. By the way, there's a very fancy name for that. You want words to impress the folks with tonight? I always provide mathematical terms. A box, I mean, we're talking about a shoebox or something, nothing terribly intelligent. Shoebox is called a rectangular, and here it comes, parallel pipe head. Didn't you want to know that?
That's like something that swims.
All right, a special case of that is a large cube. And what does special case mean? It means that the length and width and height are all the same distance. We'll call it S. And then, of course, then you still multiply the 3 together. Volume is equal to S times S times S, which is S to the 3rd power. So let's say S was 2 meters. then you're going to take 2 meters, but you're going to cube it, meaning you're going to raise it to the 3rd power, multiply it by itself 3 times. And that's 4 times 2 is 8 cubic meters. And that's going to be meters to the 3rd power. You've got meters times meters times meters. 8 cubic meters. But the whole cube idea with a unit cube and adding up all the unit cubes and so forth goes out the window now, because now we're going to talk about a cylinder. And you can't fit cubes inside cylinders. It just doesn't work. This is called a right circular cylinder. It's also known as a can of beans. Whatever. In other words, you've got a circle on top and bottom. We're sort of looking at it as an angle, and this is the radius of the circle. Of course, the area of the circle down here would be pi r squared, because it is a circle. And then you have the same exact circle up here, the same radius and so forth. And then you've got this thing over here, which is called the height of the cylinder. And it would be nice if we could find a volume formula for this that was kind of intuitively agreeable. And actually it does work out that way for the cylinder. The volume is equal to pi r squared. Now that's the area of that bottom of the cylinder itself. And then you multiply that by h, and that's it. You just multiply the height times the area of the base. That's exactly what happened over here, as a matter of fact. The base of this one, if you put some construction lines in, the base of this box back here, this thing back, you can sort of see through the lines, is this much. And then you multiply it by the height, and there it is. Now you've got the volume. Same thing happens over here. The base of this one would be this much. And you multiply it by the height, which is also S. So it seems like we can develop a lot of these formulas just taking a base of something and multiplying it by its height. And that works. That is a good result. Let's put some numbers in. Let's call the R, let's say 2 inches. And this is simply 8 inches, something like that. The volume is going to be pi times 2 squared times 8, which will be, this is a 4 times 8 is 32 times pi. And then you put in whatever pi you want to. I mean, unless they tell you in the problem to use the pi button, you could use 3.14, 22/7, whatever works. And you multiply all that out and you get your result. So we're still just putting numbers into formula letters. That's all we're doing. Okay, 2 more shapes that are often found. This one is called a right circular cone. And a cone is the shape of what they call party hats, you know, this kind of thing. Now, this one, I forgot to write this up here. This is the right circular cylinder. Now, what does right circular mean? Well, it means the base is circular, but the right part means that if you take that height measurement and go straight up, it makes a right angle down there. It's possible to have cylinders that are slanted and angled, and there's ways of getting volumes for those too. But this one is perpendicular. And likewise, here's the radius of the circle here, R, and then you go straight up, and that will be a right angle there, and this will be called H. Now, this is not obvious. What's going to happen now is kind of strange. It's going to be mystical and wonderful and so forth. But the volume of that cone, well, you might, you know, if, let's say the R here is the same as the R there, and the H here is the same as the H there, you might think, well, that's going to be less than the cylinder. And it's true, it is less than the cylinder. But how much less is not obvious at all. And it turns out to be a very precise number. The volume of this is 1/3 pi r squared H. And where that 1/3 comes from requires calculus. Okay? That's not something that we can talk about here and make any sense of at all. But it is exactly 1/3 the volume of this cylinder. So if you took this thing and fit it inside this thing, you know, let's just sort of imagine it being in there. You get something like this. The volumes would fit exactly. Then you'd have this conical kind of shape there. This that you see inside there is exactly 1/3 the volume of the entire thing, and the rest of it around the edges is 2/3. Not obvious. That's what it is. And then the last one that's always talked about is the sphere. And a sphere, the only way you draw that is to draw a circle and then put some little construction lines in it, you know, this kind of thing. So it's a three-dimensional thing with a point at the center. And once again, a sphere is determined totally by one measurement, just the radius, r. And when you start talking about the volume of the sphere, again, the formula is not an obvious formula. It's equal to 4/3 pi r cubed. Pi r cubed. There isn't anything else to measure in a sphere except its radius. So notice the volume formula only has a radius in it. There's no heights, there's no widths, there's no nothing. It's just the radius. And that determines the sphere entirely. So you would use this formula to figure out the volume of the sphere. Let's put some numbers in. Let's say we have, well, let's use the same measurements here. I call this one 2 inches and the height 8 inches. Let's put it into this formula just to see what happens. And we'll use 3.14. 2 inches, that would be 2 squared times 8. And of course, you multiply all that out. You should get something that is exactly 1/3 of that. Let's figure out if it does come out that way. If we did it all right, it should. This comes out to be 100.48. Now this one is going to be, that's 4 times 8 is 32, divided by 3 times 3.14. And that comes out to be comes out to be 100, I'm sorry, I did it wrong, let me do it again. All right. All right, 32 divided by 3 times 3.1. Ah, there it is. Okay, this comes out to be 33.49. And then it's a repeater after that, keeps on repeating. And sure enough, that is approximately 1/3 of that. That does work. 1/3 of 100 is about 33. So there you go. Now, let's give this some sort of diameter or radius. Let's call it something like 1 meter, just to see what happens. That would be 4/3 times pi times 1 cubed. And 1 cubed is still 1, so we're 4/3 times pi, which would be 4 times 3.14 divided by 3. So this comes out to be 4.186 for the bar, and that's the volume, and that would be in cubic meters. Cubic meters. Okay.
What did you do with the 1/3?
I multiply 4 times 3.14, and then I divide it by 3. See, you can do these calculations any way you want to. You can think of all of this as being over 1, so you multiply tops, multiply bottoms, then divide. You know. So you can put the order in as you wish. Okay, and that's, I think, all that they're going to give us. Yeah. So this is 509, it's page 509, 8.5. And here's the one.
Back up?
Yes, we're done with the geometry now.